Hello, I'm Trisha, a Mapuan student studying Bachelor of Science in Civil Engineering. Meet John. Like you, he's a student. And like you, John struggles with not having enough knowledge about structural systems. And that is why I'm here to show you the different types of structural systems. Vector-active structure system. Vector-active structural systems are systems of short, solid, straight lineal members in which the redirection of forces is effected by multi-directional splitting of single force simply to tension or compressive elements. These are the type of vector-active structure. Flat truss. All members and nodes lies within a two-dimensional plane and it consists of straight members connected at joints. For the types of flat truss, we have Hoe truss, Pratt truss, Warren truss, King post truss, Fink truss, Scissors truss, and lastly, Bowspring truss. The other type of vector-active structure is curved truss. It is a truss in which the top chord is in a curved shape and a truss which consists of a parabolic shape. For the types of curved truss, we have bowstring, C-yoke bowstring, arc or barrel, and lastly, C-yoke arc or barrel. For the example of flat truss, we have La Halle in Lyon, France, and its architect is Tony Garnier. For the example of curved truss structure, we have Friends Arena in Sweden, and its architect is C.F. Moller Architects. Surface active structure system. Surface active structure systems tends to reduce the surface tension of a liquid in which it dissolved or altering the properties and especially lowering the tension at the surface of contact between phases. These are the types of surface active structure systems. Folded plate structure. They are assemblies of flat plates or slabs inclined in different directions and joined along their longitudinal edges. They are also capable of carrying loads without the need for additional supporting beams along mutual edges. The other type of surface active structure is shell structure. The term shell is used to describe the structure which possesses strength and rigidity due to its thin, natural, and curved form. For the example of folded plate structure, we have airship hangars in Orly, and its architect is Eugene Freycinet. For the example of shell structure, we have Opera House in Australia, and its architect is Johan Utzon. Bulk active structure system. Bulk active structure system experiences bending loads and the whole material in the section resists bending. High quality material is consumed since it is the actual depth that works. The principle of bulk active structure system is the distribution of load in two directions. There are two elements in bulk active structures. First is vertical elements. Under vertical elements, we have columns. Columns are structural elements that transfer the load of the structure to other structural elements. And bearing walls. Bearing walls is a compressive member that is continuous on one direction, distributes vertical load, and gradually transfers it to the soil. The second one is horizontal element. Under the horizontal element is beams. A beam is a linear structural member with loading applied perpendicular to its long axis, such as bending loads. These are the example of beams. The first one is simply supported beam, the second one is cantilever beam, the third one is fixed beam, and the fourth one is continuous beam. For the example of bulk active structure, we have Clamart Sports Center in Clamart, France, and its architect is Gaëtan Lepenuel Architects. Form active structure system. Form-active structure systems are those active structures in which loads are taken by the form or the shape of the structure. This is also known as adaptive mechanical structures, in which the form of the structure or building can be altered mechanically in response to environmental changes. There are 4 types of form-active structure. The first one is cable structure. It comprises of non-rigid flexible cables shaped in a certain manner and fixed at the ends to span the space. The second one is arc structure. It is a compression form in a vertical or horizontal structure, curved in a manner that spans a space. The third one is tent structure. Tent or tensile structures are the common type of thin membrane structure which only carry tension stresses and no bending or compression. And the fourth one is pneumatic structure. These are the type of membrane structure which are stabilized by the pressure of compressed air. For the example of cable structure, we have the Golden Gate Bridge in San Francisco, USA, and its architect is Joseph Berman Strauss. For the example of arc structure, we have Galerie des Machines in Paris, and its architect is Blavet de Glaine and Eugene Hennard. For the example of tent structure, we have Munich Olympic Stadium in Munich, Germany, and its architect is Frei Otto. For the example of pneumatic structure, we have Tokyo Stadium in Bunkyo City, Tokyo, and its architect is Takenaka Corporation and Nikken Seikai. Why are these structural systems important? Structural systems are pivotal in construction, serving key functions such as safety and stability. It is designed to endure gravitational forces, wind, earthquakes, and environmental factors, ensuring occupant safety and structural stability. Functionality. It supports the intended use of a structure, ensuring it effectively accommodates activities and purposes. Durability. It resists weather conditions and stresses, maintaining structural integrity over time. Economic efficiency. It optimizes material use for cost effectiveness in construction, vital for the project budget management. Architectural integration. It influences architectural design to meet safety standards while fulfilling aesthetic requirements. Adaptability. It must adapt to changing environmental conditions, technologies, population growth, and usage patterns. Sustainability. It emphasizes eco-friendly materials, energy-efficient designs, and environmentally conscious construction practices. Compliance with regulations. It adheres to local building codes, standards, and regulations for minimum safety and legal requirements. Risk mitigation. Proper design helps mitigate risks from natural disasters, accidents, or unforeseen events, safeguarding lives and property. Innovation and advancement. Ongoing research leads to innovations in materials, construction techniques, and design methodologies, advancing structural systems. In conclusion, structural systems like vector active, surface active, bulk active, and form active are systems crucial for stability, load distribution, and adaptability in construction. They offer efficiency, versatility, and innovation, ensuring safety and sustainability in architecture.
You are watching the Principio Tectura Studio channel. Subscribe if you want to see more content about architecture, design, and Principio Tectura, and give us a like if you enjoy this video.